А в нас буде один з снеп-токів від Максима Войтко. А Максим, він є Head of Data and AI у Honeycomb Software, лідер у сфері Data та AI з понад 8-річним досвідом у технологіях, і він очолює команди з розробки та досліджень у Honeycomb Software. Спеціалізується на Data Engineering, Cloud Computer, ML, MLOps, Computer Vision і Generative AI. Під час цієї доповіді Максим нам відповість на наступне питання. Why MWAA an exceptional AWS Managed Service? Тому давайте почекаємо і дізнаємося відповідь на це питання.
Hello, I would like to tell you about why AWS MWAA is an exceptional service. I am Maksym Voitko. I have more than 8 years in tech, and particularly in data engineering and AI. Currently, I am heading up the data and AI teams at Honeycomb Software. Previously, I have worked in startups, scale-ups, and enterprises. So, AWS managed workflow for Apache Airflow. First of all, it's a managed service for Apache Airflow, and the AWS guys and girls promising that you will gain improved scalability, availability, and security without the operational burden of managing underlying infrastructure. And I would like to doubt a bit this statement because I guess still many challenges of the operational burden remains. The first one is lack of debugging transparency. So MWAA abstracts internal components like scheduler, DAG processor. You don't see anything what's going on behind the scenes. You see only the environment in general of the Airflow, and you have no control of what's going on there. And if you have worked extensively with Airflow before, you know that sometimes you need to dive deeper in some components to understand the issue. But with AWS Managed Workflow for Apache Airflow, you have limited visibility beyond CloudWatch logs. So somewhere deep inside AWS CloudWatch metrics, you can find some metrics for specific components, but nothing more than that. Debugging, and that's why debugging the performance issues can be a blind spot, because you don't understand what's the problem with which component, what you need to tweak, even on the level of configuration of the components. The next big thing is that the redeployment of the environment is delayed, to say the least. So there is no possibility to restart the environment. You can update it, but basically this triggers the redeployment of the whole Airflow environment. Just a spoiler for you, Airflow runs on ECS Fargate, inheriting all its scaling and deployment disadvantages, like the deployment time. So basically, when you update the environment of the Airflow, all the services in ECS and all the containers will be redeployed. And if you know Fargate, you know it takes some time. So it can take up to 2 hours for Airflow because of the complex setup. And if a key component like DAG processor remain unresponsive, there is no way to fix the sorry for that, guys. If a key component like DAG processor remain unresponsive, post deployment, the only way to fix it is redeployment, because there is no way to to trigger the redeployment of only one component of Airflow. So the next thing is version compatibility nightmares. Why I call it nightmares? Because Airflow version updates and upgrades are on you as an owner of the platform. So as you know, you need to update the DAG dependencies with the constraints are tied to the Airflow version. So I guess it's okay if it's a minor, if it's a patch version, but if it's a minor version, even if it's a minor version, not to mention the major, you need to recollect DAG dependencies, which require manual interventions, because basically if you want to run Airflow in private mode, so you don't have access to public PIP, to public PIPE, and you need to download all packages and on your machine, either on your machine or somewhere in the cloud on extra machine, and you need to check if the installation is okay, and if you check it in the Airflow environment itself, which is almost the only way to do it properly. One iteration of redeployment takes up to 2 hours. Again, so you can test this setup on local Docker container, which is not nice because it's platform specific and you can catch a lot of bugs there because your local environment will be different from the AWS MWAA, or the recommendation from AWS engineers who are working on Airflow team to use ECS Fargate for that. So basically you need the service on Fargate just to package the environment, package the dependencies, and to build the service on AWS MWAA. So you can catch particularly rough problems on ARM architectures because the dependencies, the binaries may be different, and you need to look closely into it. Incomplete monitoring tools. So you do have basic DAG monitoring via CloudWatch, but no detailed monitoring of internal Airflow components. And the nice thing, I guess you can value the touch of AWS engineers. They provide custom scripts for debugging and creation. So how it is run, it's not easy to find this script in AWAA documentation, but there is a run book for troubleshooting in AWS System Manager, which basically runs all the checks like networking, like security groups, like configurational issues, IAM roles and permissions and stuff like this. But this is a completely separate setup from AWS MWAA. I know why, because I guess it should be like the first step of the wizard of creation, AWAA environment, but it's like this. You can find the link here because it's, as I have said, it's not easy to find it in the AWS documentation. Complexity of MWAA networking. So since there are a lot of under the hood components of MWAA which are not exposed, but you are still responsible for configuring the networking, and this is like super an obvious design choice, because if the internal components are not exposed, why we as users should be responsible for configuring the networking setup? Like, for example, you need to configure the networking configuration for S3, SQS, Secret Manager, and stuff like this. The documentation for the networking is quite poor, and it combined with possible performance bottlenecks which may be caused by network misconfigurations. So example, if you add an SQS endpoint, it can drastically improve the dark processing speed because AWS under the hood use SQS for scheduling the workers and DAGs. So the VPC endpoint is a direct point for network to SQS service, and you won't find it documented anywhere, but if you do run the tests, the speed would be much better. The last thing that usually the trade-off between managed and self-managed services is much more obvious, so it's just the cost of maintenance versus the cost of the service. But here you need to pay more attention to estimation of the efforts, because even the managed service does reduces infrastructure management, but it introduces its own complexities, and there will be quite some effort for maintaining even the managed Airflow service. With self-managed Airflow, it would be much easier to monitor and control, but probably still more maintenance. I'm not arguing against MWAA because we are using it in production. I just want you to have easier time estimating the effort for the maintenance, and don't have an illusion around how much time and efforts it would take for supporting the Amazon Managed Workflow for Apache Airflow. Thank you for your attention. Feel free to send any questions to my LinkedIn page. I will share it in the presentation. Thank you. Bye.